Hey everyone, so we are going to start off this week by doing 1.6 and then we're going to jump to chapter 11, okay? So 1.6 is all about polygons. This whole week should be a very easy week compared to probability for you guys, and a lot of it's just going to be some review, so good news, okay? So we have a polygon. I have our definition here as a closed figure formed by a finite number of coplanar segments called sides, and the sides that have common endpoints are non-collinear. And remember all that means, they're not in a line. So we have each side intersects exactly two other sides, but only at their endpoints. And then finally, a vertex of the polygon is the vertex of each angle, okay? So using that specific definition here, we have to circle the following polygons. So remember, it's basically any time that we're not having lines intersect anywhere other than endpoints and we have straight lines. So I'm going to suggest you pause the video here and see if you match what I do, but I'm going to go ahead and start circling these here. Okay, so we should have had, let's see, how many is that? 6 of these circled here. Now, the reason that these highlighted ones right here, this one is not a polygon, is because we have a hole. Here they clearly intersect. Here we have curved lines, and then again right here for this one, it's intersecting one of those sides, okay? So we also have concave and convex, which are two ways to classify polygons. And I believe we talked about this earlier, but now we're going to go in a little bit more detail here. So a concave, I know it's a long definition here, but it's a polygon where there is a line containing a side of the polygon that also contains a point in the interior of the polygon. So what I like to do is actually extend the sides of the polygon. And as you can see, if I were to extend these sides down at the bottom, the sides actually go inside of the shape right here. So I always think you go in a cave. So if the lines extended go inside the shape, you know have a concave polygon. I know it's kind of corny, but that's how I always remembered it when I learned it. And then we also have convex, so that's where no line that contains both a side and point in the interior of the polygon. So again, if I were to extend all of my sides here, clearly none of those sides when extended are going to go inside my actual shape, so I have a convex. X, I always think here, X means no, it does not go inside, okay? And we have a convex polygon that is both equilateral and equiangular is called a regular polygon, okay? So an irregular polygon is a polygon that is not regular. And I know that sounds redundant, but that's technically how you would define it, okay? Now, going down here, you should know all of these formulas, but just in case you need a refresher, your circle area, remember that's pi r squared, and your perimeter of a circle is the same thing as your circumference, which we have 2 pi r, or we have just our pi times diameter. For our triangle, we would have half times base times height. Our perimeter, we obviously add up the sides, so using that triangle down there, a plus b plus c. Our squares area, we just do our sides squared, and perimeter would be 4 times our side length. And our rectangle area is length times width, and perimeter is 2 length plus 2 width, okay? So for these first few examples here, we're gonna go ahead and do A and B together, and then you guys will do C and D and check your answers with the notes. So for this first one, we have to name each polygon by its number of sides and determine if it's concave or convex and regular or irregular. So first, let's count the number of sides. So we have 1, 2, 3, 4, 5 sides. So a 5-sided shape here. I'm going to write 5 sides. That is called a pentagon. So even though it doesn't look like your typical pentagon, it still is because it has the 5 sides. Okay, so then determining if it's concave or convex. Remember, extend your sides if they go inside of the shape, which we can see right here they do, that's automatically it's going inside of the cave. Think about that. So we know that it's going to be concave. And if it does ever say to show how you know, extending your lines like this is more than enough for me, okay? And finally, if it's irregular or regular. So based on what we are given in this picture, okay, we have no sides are equal, we have no angles are equal, so we're going to say it is irregular. And again, if we needed to explain here, we would say no congruent sides or angles. Okay. And then let's look at B here. So if we actually count out all of those sides, I'll tell you right now so you don't watch me count them, we have 14 sides. Now 14 sides, this is actually called, I don't know if any of you know, a tetradecadon. I'm gonna run out of room here. A tetradecadon, okay? I personally am okay if you only know up to 12 sides, which is a dodecahedron, okay? But 14 sides is a tetradecadon. And for our concave convex, right away, we should be able to tell that if we were to extend these two sides here, they're going to go inside. So again, you're going in the cave, so it's concave. And then this one, it does look like we have a regular polygon, but because we don't actually have that the side lengths are congruent in our given drawing, we would have to say irregular, and then our reasoning would be either no congruent sides, or we could say only congruent angles. Okay, so I'm going to suggest that you do those next two there on your own, and then check your answers with the key. But we'll go ahead and move down to 2. I'm going to trust that you guys can do on your own, check your answers with the key. That should be very simple review for you. Okay, and numbers 3 and we'll just do number 3 actually together. Find the perimeter of a rectangle that has a length that is 3 times the width and an area of 27. So we can see that the length is equal to 3 times our width, so 3W. So we know that the area is 27. So remember, our area of a rectangle is length times width. So we can say 27 is equal to our 3W, which is our length, times our width. And we would get 27 is equal to 3W squared. So again, we want to solve for W. To do that, we're going to divide both sides by 3. We get 9 is equal to W squared. So W would equal 3 and negative 3. But technically, since this is a side of the rectangle, it would just be that positive 3. We could not have negative 3 as a side. All right, so now that we have that W, we also have to find the perimeter. And to do that, we need to make sure that we have the length. So remember, we have our length is 3 times our W, which we just found to be 3. So our length is going to be 9. So for our final answer, our perimeter is going to be 2 times that 9 for our length, plus 2 times our width, which is 3. And we get 18 plus 6, which gives us 24 inches. Notice how up here we had our area in square inches, okay? Now I'm going to say you guys do number 4 on your own, and we're going to move down to number 5, and I'm going to have you guys do number 6 on your own. So we are going to be finding the perimeter and area of these shapes here that we're going to graph. So that means, of course, we're going to use your favorite formula in the world, the distance formula, okay? So let's graph our first thing. We have our triangle PQR. So P is at 0, 0. Q is at 3, negative 2. R is at 5, 0. Okay. Goodness. All right, so once you have that, we should be able to find the perimeter pretty easily, okay? So what we need is our 3 side lengths, and one of those, PR, is going to be really simple to find because it's already on a straight line. So we go from a value of x being 0 to a value of x being 5, so PR is just going to be, R5. And then for QR, we're going to use our distance formula, like I said. So we'll have our change in x, so x2 minus x1, we'll do 3 minus 5 squared plus negative 2 minus 0 squared. And not to bore you with me working all that out, if we jump right to our answer here, QR, we should get 2.828, okay? And now I know it doesn't say what to round to, so as long as you round to your nearest hundredth, I'm fine with that, okay? And then we also got QP. So again, if we set up our distance formula correctly, we should have 3 minus 0 squared plus negative 2 minus 0 squared. And we're going to go ahead and get, let's see here, 3.606, okay? So now that we have our three side lengths, our perimeter is going to be really easy to find since we just have a regular triangle. We're going to just add up all those side lengths. So 5 plus 2.828 plus our 3.606. And if we add all those up, we should get 11.434. And since we don't have any units specifically, I'm just going to label that as units. Okay. And our last step here to find our area, remember for a triangle, we just need our base and our height. So looking at this triangle, we can see that PR is already on that straight line, so we're going to act as if that's our base here. Okay? And then it's really easy for this one. Our height, remember, is just going to be perpendicular to your base. And this one works out that we can just count it. We can see that that's going to be 2. So for our area, all we have to do is 1/2 times our base, PR, which is 5, times our height, which is 2. And that's easy enough. We get 5 units squared. Just make sure you label your units all the time for these, okay? So the rest of this, I'm going to leave you guys to do on your own, and then make sure that you're checking the homework on Google Classroom rather than your syllabus, because I did shorten it for you guys. And if you have any questions, please let me know.